Greetings once again, everybody. This is lesson 15, trigonometry for students and surveyors. We're getting pretty good use out of this polygon traverse, closed loop traverse we did. We've done everything, added angles, created our bearings or azimuths from angles. We created the angles from the bearings. We came back again and we did coordinates. We created coordinates from our cosine and sine of the zenith angles and the distances to give us coordinates around there. Then we came back and we did a closed loop traverse. We just added all the angles and we used our formula n minus for interior angles, the number of angles minus 2 times 180, and we checked all those. So we've done all that. And then we flipped over and we did measured the tree again and used different ways to do that. We were basically, that second half of that was about vertical. We're back here. So what we're going to do now, you have coordinates, and then we're going to move on in a few episodes or a few more lessons, and we're going to just start with coordinates. But here, how do you get the angles and the bearings if you have a coordinate? We're going to have coordinates and go and do inverses. Inverse is a very important thing for surveying, or I guess for any other kind of calculus or CAD drawings. Inverses, you're basically inversing from one coordinate to another coordinate. In this case, we're going to start with 6 and 5. 6 and 5. On the data collectors on that, when you shoot a point, you shoot another point, you can just inverse quickly between these 2 points. What that inverse will tell you will be the distance, and it'll tell you the bearing or the azimuth. As usual, I juxtapose those all the time. If you have elevations on those coordinates, it'll also give you the elevation difference in percentage, angle, however you had it set up. We're just going to use two-dimensional here. We're using XY coordinates. We don't have elevations on these. As we progress, we're going to do XYZ coordinates and do some stuff that way. So let's get started. What you do when you're inversing, if you're going to figure it out longhand like this, is you subtract the northing from your 2 points, and your easting from the easting from your 2 points. And you start with, so on this one, we're going to go from 0.6 to 0.5. 0.6 to 0.5. Now I've drawn these little north, south, east, west just to make it easy to see what quadrant we're going at, because you don't have a bearing there, and who knows, this whole picture might be rotated, but this is roughly the way it is, north, south, east, west. So we're going into the northeast quadrant. And if you recall, when we did sine and cosine, the northeast quadrant is north and east, which means it's positive and positive. If you use sine or cosine, anywhere from 0 to 90, you're going to get positive and positive. And if you start, we already went through all this, so I don't really want to repeat it, but if you go to the south, you're going to get a positive easting, or if you're going to the southeast quadrant, you get a positive easting, but a negative northing. And over here, southwest, you're going to get a negative northing and a negative easting, and up here you're going to get a positive northing and a positive easting. That'll all be reflected when we start doing the math on these northings and eastings when we start subtracting these. So you just keep that in mind. Keep in mind too, you don't have to change your negative signs and get rid of them or add them on there. You just leave them, and you don't have to subtract. We're going to add bearings, but we're not going to subtract bearings. You'll see it'll all come through. So since we're going to, and also remember when I saw converting azimuth to bearing or bearing to azimuth, when you're in the northeast quadrant, you don't do anything. It's the same number. 0 to 90 is 0 to 90. It's when you come down here 90 back to 0, and so on and so forth. We talked about when I had the big circle here, anything on the southern hemisphere, you used 180 to calculate or to convert bearing to azimuth, 180 this way, and you just have to figure it out. 180 add or subtract, 180 subtract. And if you're up in the northwest quadrant, you use 360 to figure out, to convert from back and forth the bearing to azimuth. So let's get started, like I said at first. So we're going to start with a northing of 6. The northing and easting of 6 is 6314, 6835, and that's the easting of this one right here. But right now we wanted to get the difference between the northing of these two. So 6 is 6314, 6835. 5, the northing of that, is 6649, 7507. Subtract those and you get a negative 335.0672. So if you're going northeast, why are you going negative? Well, it makes sense if you really think about it. You're going from, if you're going to the east, you're increasing your numbers. They're getting bigger as you're going. And if you're subtracting from this one, you're going to have a negative number. Okay, so then that's our attitude there. That's our answer there. And over here on the easting, you're subtracting the easting from the easting. We're subtracting 6. So the one you're going to, direction you're going to 6, you're going to 5. Those are your ones you're subtracting from. So we're going to subtract 4831, 4046. That's the easting. 5634, 7157. That's the easting there. And that is 803311. All right, now I've talked a lot about storing numbers and how handy that is to do that. So we're going to I'm going to go store that. Now this, when I have 7, again, it's not plus 7, it's 7 is just the key that I can store it in any key I want. But I picked out 7 and I already explained why I do that. Northing is 7, easting is 3, north, east. My angle is, my finished angle is in 0. My decimal angle is in 1. That's what these are about. Decimal angle 1, the hours, minutes, second is in 0. Okay, let's get going here. So 335.0627, it's a negative. So 335.0672, I'm going to add a negative to that. And I'm going to store that as 7. Now my departure is negative, or 803.3111, and that's a negative. I'll add the negative to that. Now, before I said you wouldn't have to add or subtract negative, you wouldn't if you just subtracted that. I'm just copying it off of there. This was the only reason I'm adding it. If I just subtracted that, it would come out negative and I would just store it. So don't be confused about that. Now let's do the negative there, 803, negative. Okay, now we'll store that as 3. Now as soon as you do that, so you want, it's called latitude and departure. That's what coordinates are. And when you solve it, it's departure, D and L is departure over latitude. So let's get to that. So you've got that number, you've done this math and you've got that number and stored it as 7. You've done this math, you got that number and you stored it as 3. Well, now that's in 3, just recall 7, because see, this is your departure, and now divide. And you got 2.3975. Okay, now you want the arctangent of that. So you remember, we're just doing triangles. We're doing right triangles, that's all this is again. We've gone 335 that way and 803 that way. That's constantly right triangles. That's why we started all these lessons with right triangles, and we looked at them over and over and over again and solved them every which way we could. So there we are. So now we want the arctangent of that. Why is it the arctangent? Well, we're doing a side and a side. You know, okay, so we're not doing the hypotenuse, we're not doing that yet. So the side and the side, the arctangent is, and 6735.86, that's the decimal. Now I'm going to store that as 1. 6735.86. Now if you convert it, you're going to get 6721.31. That's the bearing. That's the azimuth. Azimuth and bearing going to the northeast are exactly the same. They're just maybe a written difference. If you're going to write that as bearing, it would be north 6121.31 east, and if you're writing it azimuth, it would be just 6721.31. Okay, so now we have that. All right, so we've got we're inversing between 2 points. We've got our bearing. Now what about our distance? Well, we want the hypotenuse of that. So we could revert back to the Pythagorean theorem, a squared plus b squared, c squared. So we would square these, add them together, and then take the square root of that, we would get that. The other way is we already have this number written in. So we're going to use it that way. So we're going to recall 1, 67, 35, 86, and now we're going to go cosine. Remember, cosine, we're looking for this distance, and we're looking where it's connected. Now, if this was 0 in the CAD drawing or in the regular Cartesian coordinates, we would use sine. But since we're using zenith as 0 up here and 90 over there, we're using cosine. We went through all that. So cosine and that. Now we want to inverse. We want to 1x that because that's just what you do when you're looking for the hypotenuse. 1x 2.5977. Now we want to recall 7, which is our northing, and multiply that. And it's 870. I don't think I ever figured that one out here. Let me see here. It is 870.39. That is correct. I never wrote it down there. So we'll write it in here. So we're going to go 8. It actually comes out as a negative, but that's fine. 870.3900. So that's your bearing. That's your distance. You just inverse between 2 points. Now, as I said, because it's 90 degrees off, we can also do that with a sine. So we're going to recall this number here, this decimal, and we're going to go with the sine of that. It's 0.9229. Well, we know the hypotenuse is longer. So we're going to 1x. Remember, if you don't like the 1x, you can always do a division to start with, but I always like to just multiply. 1x is 1.0835. Now we want to recall our departure, which is our easting. So recall 3 and times that. 870.39, a negative 870.39. So there, we've just inversed that one. Check the distance. We're good. All right. So there's that one. Now let's go to this guy here. Now we're going inversing from 3 to 2. The reason I want to do that, I've picked out 4 of these, so we've gone every quadrant. We went that quadrant, and remember, do not add an angle to this quadrant. The next one, we're going to add an angle. And we're going to go from 3 to 2. So this is 3, and this is 2. Nice long, it's almost down, straight down. So we're going to go 3 to 2. And that's over here. So there's our northing on 3, and there's our northing on 2. We subtract those. I'll just go ahead and put that in there as 706.1297. And I'm going to store that as 7. I'm going to overwrite that one, store that as 7. So store 706.1297. Now our easting, 3, we're going from 3 to 2. So 3 to 2, our easting is 5568.1220. And so we have a negative, we'll just put that in as 185.1509, and that's a negative. Again, if I just did the math, I wouldn't be adding or subtracting the negative. I'm only adding the negative because I didn't do the math. I already pre-did the math. I'm just giving you the sum. I think you can figure that out. Now we stored that as 3. Stored that as 3. Now we already have that in there, so now we just got to recall 7. Recall 7, 706.1297, and now divide. That's a negative 0.2662. Now we want the arctangent of that. Okay, the arctangent is 1469.25, but we're going into the southern hemisphere, the southern part now, so we want to add it 180. Oh, it's a negative, sorry. It's a negative 1469.25, so we don't, now we just add 180 to that. So 180 plus, and we're getting 165.3075, and we have 165.1827, so let me store that as 1. Now we'll convert. 165, 1827. So that's this one. And you have it right there. So this is the bearing. Okay, there you are. And that's written right there. Now we've stored this as 1, so we're going to recall 1. And now we're going to find our distance, our hypotenuse distance. Recall 1, and we're going to go cosine. It's a negative 0.9673. See, it's almost a 1-to-1 because it's almost straight. If it was a 180 degrees, if it was straight down, it would be a 1-to-1 ratio. Be 100% ratio, but it's not. It's close. And now we want to 1x that. And now we have a negative 10338. Now we want to recall our northing difference, and multiply that. And that's 730. 730 feet. Now if you go back to the old lessons, you'll see that that's all in there. 730 feet. So now we've solved that one. Now we can do the same thing again. We can recall the angle, and we can go sine 1x that, recall the easting, which is also the departure. It's also departure over latitude, and that is 185, and I guess times 730. So we're good there. So now we've gone northeast, we've gone southeast. Our next one is 4 and 5. Let's go northwest. So we're going to go northwest with 4 and 5. Okay, I'll show you this time. I'll just go ahead and do the math. 6402.8155. Enter. That's our northing for 4. Now we're going with the northing for 5. 6649.7507 minus, and now we're getting a negative. That's what I meant. You don't have to add that. Once you do your math, it's just there. So now we'll just store that. Store as 7. And then I already did the math here, so I'll just go ahead and copy that over. 384.7314 and store 3. I think, let me just double check. Negative 246.9352, recall 3, 384.7314. Okay, so I have that in there now. That was the last one I calculated, so that's in there now. I just recall that, which I have stored in 7. Remember, it's departure over latitude. Departure is east and west, latitude, north and south. And that's because it's sine, or 0 and 90. That's why it's that way, or else it would be the other way around. Where am I here? So divide. Okay, I got a negative 15580. Now I want the arc tangent. There it is. So I want the arc tangent of that. Now on some calculators, I've said this before too, but I'll repeat myself. So this one has arc, a tan, a cosine, a sine. Some will have an I. It means inverse function of tangent. Inverse of tangent is the arc tangent. Just different way they label them. So keep that in mind. Figure out how to use that. And I want the arc tangent of that. I think that's where I'm at. I'm getting lost here. Okay, that's a negative 5730.61. Now I want to add that. Where am I going here? Oh, I'm doing this one here. So I want to add 360 to that. When you're in this quadrant, when you're going to the northwest, remember, just like I showed you when you're converting bearing to azimuth, you go from 360 this way. Same when you're doing this, you're adding 360. You have a negative number, you're adding 360, and you have 302.6939. 302.4138. Let me just store this as 1. I'll convert it now. 302.4138. That's right. And that's your azimuth. And if you want to know what that was from in bearing, you just subtract that from 360, then you'd have your northwest bearing of whatever that would be. Okay, so there's your that. Now let's get our distance. Again, you could go a squared. You could go a squared plus b squared. If you wanted to do it that way, you'd be going a triangle like so. And that's why we're going to use cosine. They're connected here. So we're going to go recall 1. That's my decimal figure. That's this guy right here. And now we're going to go cosine 0.5402. We're going to 1x that. So we have the hypotenuse, and then we're going to recall the northing, that one, and times 457.16. 457.16. We'll put it over here. There it is. That's your distance, that's your bearing, that's your azimuth. Now we can do the same thing, recall 1, that's our decimal angle or decimal azimuth. And we're going to go sine this time. We'll 1x that. That's a negative 0.8416. We'll sine that and then recall the easting now, the departure, and times that, and 457.16. So we get the same thing. Now if you did a squared, b squared, c squared, you're going to get the same thing. So we're doing good. We've got 3 of them. So this is really what you need to pay attention to. If you're going to the northeast, you don't add anything. If you're going to the southeast or southwest, you add 180. If you're going to the northwest, add 360 to whatever that is. So now let's do this one here. Just so I can sit down for this one. Now because we're going in a negative direction, both of these are going to be positive. Does that make sense? Well, it's because you're starting with a bigger number here. We're going from 7 to 8. We're doing this run here. We're going 7 to 8. So you got a positive number northing. If you're comparing this one, you have a more positive number northing and a positive easting. So you subtract, you're going to get a negative number, or you're going to get a positive number. 365.0369 is the northing. When you subtract the northing from 7 from the northing from 8, 365.0369. Let's going to see. Well, these are the northings and eastings, so you could write those down. I should have a chart like this. Maybe you guys can take a snapshot of that, store it, do a screenshot of that. I think I had all these to start with. That's why if you go back in earlier lessons, they're all there. Anyway, so let's go with 365.0369. 365.0369. Again, store that as 7, which I did under key 7. And the other one, subtract the eastings, 7 from 8. Always put the one from where you're going from your origin to your destination on top and subtract, or you're going to get the wrong answer. And that answer is 554.0431, 554.0431, and we'll store that as 3. Now we have those. Now we're going to recall this guy, departure over latitude, and divide. 1.5178. That got smeared. Okay, now you want the arctangent of that. That's a ratio, so you want the arctangent of that. 566207. Now you want to add 180 to that. See there? We're here. Now we're going to add 180 to that angle. 180 plus 236.6207. And I'm going to store that as 1. We'll convert it. 236.3715. And that is correct. 236.3715. (236 degrees, 37 minutes, 15 seconds). That's the azimuth. Again, now we're going to calculate the hypotenuse. All right, so now we're going to recall 1. That's the digital angle, their digital azimuth, 236.6207. We'll go cosine. It's a negative 0.5502. We'll hit 1x and recall this number under 7. That's your cosine number, that's your northing, and times 663.4875, and I have 663.4875. 663.4875. That's your distance. Okay, now we're going to do one more time. We'll just do it and recall that decimal angle, decimal azimuth. I'm getting better. And then we're going to hit sine, and then we'll multiply times the departure, which is the easting. So we're going to recall 3 and times. I didn't reverse it. So we're going to recall 1. We're going to go sine. I didn't hit 1x. I didn't reverse it because I have is negative 0.8350, which isn't going to account for a hypotenuse. So we'll go 1x. Now I have a negative 1.1975, and then recall 3 times 663.4875, and there we are. Now, with northings and eastings, you can inverse anywhere you want. You can inverse from 2 to 6, from 1 to 5, from 4 to 6. It's just as easy. I picked all these out because we already had all, we had all these bearings, azimuths, distances. We already had them from the earlier lessons, so you can go back and check and see how all that worked out. I forget what, it's about 4 lessons ago. We've been moving along pretty good here. But that's how you inverse if you're traveling up and need to travel right back to what you're back to the beginning. And that's something we're gonna do, rotate our traverses. That's where that's gonna come in very handy too, is to know how to do that in theory. And then each data collector, whether it's a Trimble or Leica or whatever, Carlson survey, whatever, they all have their own little ways to do it, their own particular ways to do it. But as long as you know the theory of it and what's going on, that's going to help. So I guess that is a wrap on this today. Please like and subscribe. And if you're a surveyor or student, anyways, pass this around. Push this out there. And I hope people can really get a benefit out of this as I step by step everybody I can through this trigonometry for surveyors, for students. Okay. Like and subscribe.